Good afternoon, everybody. My name is Philip Moss, and I am Chief Product Officer at Accutech, who are a UK-based service provider. And I get to do something really fun for the next 45 minutes. I get to basically cover every single thing in Server 2016, so at the end of this session, you'll go out going, wow, there's some really cool stuff here. Now let's go and learn about some more. However, as a service provider, I actually only really care about two things. One, making stuff that my customers and my users actually want and need. Stuff that actually worked. Two, driving down cost. Because at the end of the day, as a service provider, my business is about making money. Now, that means, generally speaking, I have a very different view of IT than most other organizations, because to me, it actively affects my bottom line. Stuff has to work, stuff has to be reliable, and stuff has to be cost effective. Now, I am a great believer in the concept of the software-defined data center. And this is a concept that Microsoft and myself, people who have attended other talks I've given in the past, have been talking about for a while. The power of the software-defined data center. This idea of using commodity hardware and commodity software to reduce complexity, drive down cost, and increase scale, all using standardized software stack, standardized hardware stack. And what that really means in the real world is move to a unified software stack where we can attain 100% virtualization with 100% automation using, and this is the really important thing we'll talk about a lot in Server 2016, validated hardware with firmware and drivers. Now that's quite a big change, because what that means is we're now talking about solutions that actually are taking all the power and the advantage of software-defined data center with this great software stack, Server 2016, but we're doing it on top of hardware solutions that have gone through rigorous testing, end-to-end solution testing. Fundamental change in the way we're going to think about software-defined data centers. So, let's kind of do a bit of history, a bit of a history talk first of all. If you remember, and I'm sure a lot of you have been in this industry for a long time, back in Windows 2012, Microsoft delivered its first software-defined data center vision. That was the vision where, as an organization, Microsoft delivered storage, network, compute, and services as an integrated end-to-end software solution. It's the first time you didn't potentially have to use a third-party solution. Then 2012 R2 came along. And basically, and I'll be polite here, everything worked finally. It's quite good. I see some laughter in the audience. People went through that phase. And it was quite good because a lot of the issues inside 2012 actually got fixed. And some of the promises of 2012 actually started being delivered. So 2012 R2, good news story. Then we come to Server 2016. Server 2016, actually, Microsoft has redefined the software-defined data center story. And I mean really redefined it. They've driven down the cost to serve considerably, added a whole bunch of fundamental new services, at the same time clearing out all of those blockers that we had in 2012 R2 around scale and manageability. That's a really good news story. Here's the bad news. Everything you know about 2012 R2, go find a trash can. Just put it in the trash. New learning curve, new paradigm, new approach. So what I'm going to talk about today is a lot of that conversation. So I'm going to focus on end-to-end design, end-to-end solution design on Server 2016. I'm going to really try and talk about some of the practical considerations. I'll let you into a little secret. For our organization, Server 2016 isn't new. We've had it in production for approaching 3 years. Now, what's interesting about that is we have some interesting insights on what that means. So hopefully we'll be able to share some of that. My goal, though, at the end of this session is to hopefully let you go out and spend some time with the product engineers to deep dive into some of the services we really talk about during today's session. So let's get into the architecture of the software-defined data center. People who have listened to my sessions before will have seen this picture. So we have this idea of the scale-out file server, storage. And then we have this idea of this network transport, SMB3. Then we have this idea of Hyper-V virtualization. Does this look familiar to people? Good, good, it's encouraging. And then on top of that, we were doing things like, we were doing core platforms, we were doing software-defined networking, and then of course we were doing a services layer, remote desktop services, backup, etc. And then of course we were doing an application stack on top. Right? Fairly standard software-defined data center story. Now today, we're only going to talk about these four. So we're going to talk about storage, network, compute, software-defined networking. But in reality, the model's changed a bit. Because we now don't talk about scale file service, we now talk about something called storage spaces direct. And this idea of this SMB3 network transport doesn't really exist now because the Hyper-V and the storage layer are now combined into one model, what a lot of us call the hyperconverged model. Now, we'll talk more about this in a minute, but we really have to understand this. It's a much simpler model. We're down to 3, almost 2 layers now, compared to those multiple separate layers before. Fewer moving parts, fewer pieces of software, simpler to maintain, simpler to configure. The essence of the software-defined data center story. Now, let's get into the new OS approach. You might wonder why I'm talking about OSs at the beginning of this session, but there is a reason. Now, with Server 2016, Microsoft has released a new version of Windows Server called Nano. It is a fundamentally new approach to Windows Server. Ultra lightweight, ideal for fabric workloads. Now, for those of you who have seen this picture before, it is ideal for those fundamental fabric workload activities: storage, virtualization, clustering. It's also, by the way, rather good for Windows containers and Hyper-V containers. But it's definitely, in this release, a fabric platform. So let's think about this as a diagram. I think the diagram on the right sums this up really rather well. If you think of Server 2016 as a core at the bottom, on the right-hand side, we have the traditional GUID-based copy of Windows Server. Then you have the minimal interface version of Windows Server, which, has anyone ever used minimal interface version? No, I didn't think so, neither have I. And then, of course, you have Windows Core. Now, a lot of people thought of Windows Core as being the lightweight version of Windows Server, but of course it isn't. It's still the big fat Windows Server we all knew, just without a GUI. Now, Nano Server is fundamentally different. It only contains the components we add in as a package. It only contains the core components from the ground up. There is no bloat, there is no fat. A Nano Server installation is under 500 megabytes. But it is Windows Server. And every single thing I'm going to talk about in this session can be performed on Nano. However, there is a downside. No GUI at all. Unfortunately, it's PowerShell all the way, people. So let's just recognize it's going to be PowerShell. So let's move on. Let's first of all talk about storage. Forgive me. And storage spaces direct. Many of you will be familiar, I expect, with scale-up file server. Who's using scale-up file servers today? Excellent. That's what I like to see. Good. OK. So this is a model that many of you will be familiar with, scale-up file servers. Some servers. Then we have some JBODs, some external disk enclosures, 1, 2, 3, 4. And then we start doing what I call cable spaghetti, which looks like this. Who's drawn diagrams like this lots inside their organization? Yes. Who's wired them up? Who likes doing it? Funny that. OK. So this is the model we've all been using, what is known as the shared SAS storage model. Now, storage spaces direct fundamentally changes this model. Instead of having interconnects between all the servers on all the external disks, we just directly connect the server to the disk. Now you say, how do they communicate to each other? Well, we replace the SAS fabric, connecting each of the disks to the servers and the nodes, with a storage fabric, SMB. Think about that for a second. Again, we've reduced complexity, we've driven down cost, we've got rid of those wires, and we're using commodity networking to do connections. Now, the beauty of this model, though, is that why do the servers have to be in external JBODs? Why don't we actually put the JBODs in the servers? Or more importantly, make them internal disks. So let's think about that for a second. We went from a model that was external, 4 servers or more, connected to external disks using massive cables. And now we've gone to standard commodity industry servers with local disks being able to build high-performance, continuously available storage. No complicated wiring, using commodity networking to connect the two together. So, driven down cost, driven down complexity. Now, there are 2 ways of doing the storage spaces direct deployment. The one on the left you're probably familiar with. Who's doing this today? Some storage, some networking to connect the two, and some servers separately. Well, hopefully it's most of the room, because you should be all doing this. Good. The other model is what's called the hyperconverged model, where, of course, we put the servers, which are running the scale-up file server, and the hypervisor role on the same node. Think about that for a second. So instead of running your hypervisors on separate clusters, you run them on the same cluster you run their storage, what is called the hyperconverged model. Now, disaggregated, which is the way we'll do it today, I actually prefer. And that will shock a lot of you, but as a service provider who runs at scale, I actually prefer disaggregated. The reason I prefer it is because I can scale my servers and my server compute resource independently of my storage resource. However, as you can plainly see here, the entire industry is obsessed about hyperconverged. Who's had a call from their local sales rep from their OEM lately going, here, have our hyperconverged system? Yes, I can see some nods going around. Okay. Unfortunately, not only is the industry obsessed about hyperconverged, but because of the way Server 2016 is licensed, pardon? Forgive me, the front of the desk, could we deal with this gentleman at the front, please? Yes. Guys, come to the front, please. I'm sorry, everyone, just wait a minute. Guys, can we hold the timer, please, while we deal with this? Thank you. I assume they have. Let's just check. Right, good, thank you. Where are the staff who normally man the doors? Are they out there? Right, thank you. This will be an interesting recording this year. No, they're coming. Good. Guys, I would suggest if we can just let them come around the front, that might be easiest, and then up the side. I know we're busy in here. Thank you. They will come around the front. Have we got a gangway to the right so people can actually get out? Thank you. Thank you so much. We will carry on again in a minute. Thank you so much, all. Okay. Well, my sessions can be boring, but you know. Are we okay? Are we good to go? Cool. Right, thank you all. Okay, so what I just touched on briefly was the difference between hyperconverged and disaggregated. And the interesting thing is that the industry is very focused on hyperconverged in this cycle, and because the way Server 2016 is licensed, you really need to be looking at hyperconverged scenarios for most of your deployment. However, let's now look at the hardware solutions we're going to be talking about in this release. So, here's a really important thing about Storage Spaces Direct. You really want to be using Microsoft certified hardware solutions, and most of the tier 1 OEMs have really good Storage Spaces Direct. Your scale capacity is between 3 and 16 nodes. Yes, I know that the Windows cluster can go up to 63 nodes, but your scale factor on Storage Spaces Direct is 16 nodes. Now, you need to have dual socket CPUs. Remember, these servers are almost certainly going to be doing storage and hypervisor workload. And also remember that the storage is being looked after via networking, which means you need those CPUs. You need at least 128 gig of RAM. This is not the storage solution you used to know. You need at least 10 gig, preferably RDMA networking. Storage Spaces Direct does not work with 1 gig networking, even if you start bundling it together. We are in a 10 gig and above networking world. So, you then need a minimum of 2 caching devices. And I'll talk about caching devices a bit more in a minute. And you need a minimum of 4 storage devices per node. Remember, we're now talking about servers that contain the storage and compute in one activity. Now, all of these devices, though, are connected over standard SAS or SATA. No nasty RAID controllers, nothing like that. This is standard SAS and SATA. And because I've got sick and tired of the question over the years, can I use this with iSCSI? No, you can't. And I'm very sorry to anyone in this room who's asked me that question over the years. So let's be very clear. It is direct attached storage, right? We are not doing RAID, we're not doing fiber channel, we're not doing iSCSI. Right? Let's just get that out in the open. So, as you can see, though, it's very standard commodity hardware. Now, here's the really nice thing about it. Storage Spaces Direct does not need persistent reservation, which means you can use SATA, not SAS. Now, I don't know if any of you have bought SSDs lately, but does anyone know the price differential between a SATA and a SAS SSD? It's about 30% the cost, which means those nasty expensive SSDs you were buying have just got much, much, much cheaper. Now, we also have a new media type to think about. So you're all familiar with spinning disks, spinning hard disks, and most of you I expect are familiar with SSDs. Who's worked with NVMe, non-volatile memory? Excellent. Right, we have a new class of supported memory device, non-volatile. For those of you who are not familiar with NVMe, NVMe is on PCI bus, solid state storage. The reason NVMe is interesting is its latency is lightning quick. So the caching capabilities and performance enhancing, NVMe is the way to go. And we'll talk about some performance later. Now, the other thing about storage spaces direct is data resiliency. You've basically got two options, three-way mirror or parity, or erasure coding as the storage team likes to talk about it. Now, how many of you today do two-way mirror on things? Yep, I used to. Let's be very clear. You can't do two-way mirror. This is a shared nothing storage solution. Think about it. Every time you reboot a node, your volumes are degraded. If you only do two-way mirror, as soon as you reboot a node to patch it, if you lose another disk, you've lost your data. So please, three-way mirror only or parity. We'll talk about that more in a minute. Now, we've spoken about this construct, this new construct of building our storage out of servers and using the network to connect them together, using the network to build the fabric to lay the disk data out. Now, though, let's talk about accelerating how that storage works. I expect many of you have used tiering, either on a SAN or in Scale File Server in 2012 R2. Who found tiering easy to live with? Who liked pinning files? Yeah, it's encouraging. No one put their hands up. It's always a good thing. So, storage acceleration in 2016 is fundamentally different to the way it was before. The storage bus cache, in effect, converts every single one of your hard disks into a hybrid drive. I'm sure many of you may have hybrid drives in your laptops. Those things are a combination of an HDD and an SSD bit at the front. Effectively, the storage bus cache does that automatically for you. So it takes your SSDs or your NVMEs inside of your server, splits them up, and gives every single one of your hard disks a little cache. You know, a few hundred megabytes of cache. Sorry, a few hundred gigabytes of cache, sorry. Right? And therefore, all of your I.O. passes through this cache. Think about that for a second. This isn't a question of files that I pinned go through this fast cache. All of your I.O. goes through this cache before going onto your large capacity HDDs. It also means that it gives us caching for read and write operations. Now, let's think about what effect that has on performance for a second. We now have all of our I.O. going via SSDs, and it's for all read and write, and we have multiple SSDs in the system. That gives us the ability to drive insanely large IOPS. And in fact, in one of the sessions I'm giving later on this week, we'll talk about some numbers. I won't talk about them today, but we are talking about numbers that are in the millions of IOPS. Insane numbers. Now, that all sounds like really good news, doesn't it? Happy days. However, there is a problem. There is a nasty little thing that shared nothing solutions don't like to talk about. They suck really badly at disk utilization. Well, if you think about it for a second, you have to do three-way mirror. Now, that means that you're going to lose 66% of your raw disk capacity. So for every 3 terabytes of storage you buy, you get 1. It's not a very good situation. Now, the solution to that would be to do something like parity, the equivalent of RAID 5. That's much more disk efficient, isn't it? That's kind of 66% efficiency. That's quite good. Except parity has really bad random I.O. performance. So you can't really use parity. We have a problem. We've got this great new system with really fast I.O. acceleration, but it's going to cost me a lot more because I've got to buy 3 times more disks than I did before. And that's also expensive because the disks inside the servers that have CPU and RAM. This number is not looking attractive from the cost perspective. Fortunately, there is a solution. REFS tiering. The simple summary of REFS tiering is the file system dynamically moves data between three-way mirror and parity. What this means is that underneath the covers, and this is transparent to you in operation, you don't need to do anything. Data comes in and is written to the volume in three-way mirror. The data is dynamically moved to parity layout inside the file system. This isn't happening at the volume or the block level, it's happening at the file system level. And the system is doing that automatically for you. So, net effect, you gain the performance of a three-way mirror with the capacity utilization of a parity block layout. Here's the other nice thing about it. When you create your volumes, you can control the percentage between three-way mirror and parity layout. And in fact, you can also create volumes that are purely three-way mirror or purely parity. For example, if you're creating a backup drive, you don't care about performance, you just create its parity. Now, this is where it gets very interesting, because when I started doing scale-out file server, because I'm a mean service provider who wants to make money, I used two-way mirror. And I thought, that's a good news story. I've got 50% disk efficiency. Well, with multi-resilient tiering, I'm getting 60%, I'll be polite and call it 64%. I'm getting 64% plus disk efficiency, right? Because using this combination of writing data between three-way and parity. In other words, this new technology gives me all the performance I used to have with three-way mirror, but with a disk efficiency that is better than I had with two-way mirror. One more thing to think about here. Because it is a parity-based layout, the disk efficiency gets better as I add more nodes to the system. So, as I go from, say, 5, 6, 7, 8 nodes, the overall disk efficiency gradually gets better. And it can get as good as about 70% disk efficiency. So let's think about that. I'm getting 70% raw disk efficiency in a system that all my I/O is accelerated by an SSD or an NVMe. And I get all the advantages of three-way mirror with a capacity expansion of parity. Oh, and by the way, I get all of this inside of Windows Server. Cool? Good. I think it is. I know I don't have any hair, but I still think it's cool. So, now we talk about Storage Spaces Direct. Now let's talk about the health service. There was a problem with 2012 R2. 2012 R2 scale file server was really hard to manage. For the people in the room, who found changing hard disks easy in 2012 R2 scale file server? No takers? No takers? The quote I have up there is actually very true. For those of you who have used CPS, Cloud Platform System, the manual for changing one hard disk was 12 pages long and recommended 3 engineers. Fortunately, Microsoft realized this was a problem and delivered something called the health service. The health service takes the challenges of monitoring, operations, and maintenance and turns them into self-monitoring, simple operations, safe maintenance. Now, what that really means is that you know what's going on, you can't shoot yourself in the foot, right? And the system's going to report when problems happen for you. I won't go into the details of health service here because we're doing a session on it later on in the week. But here are some high-level highlights. You can finally get aggregated throughput and performance data for your scale-out file server or for your Storage Spaces Direct solution, aggregated from a single PowerShell command. The system now manages for you the process of replacing a hard disk. You can now just pull them out, you can poke them back in. The system stops you doing silly things like rebooting the same node that has the same set of data on. In other words, it's quietly in the background, looking after you, making sure things work. Fantastic new capability in Server 2016. Now, the good and the bad. This is the stuff you don't see from the Microsoft slides. So, here's the good things. We can go up to 16 nodes in the scale-out file server. That's a really good news story. That drives down costs considerably because now we can use these cheaper disks, we can use SATA disks, etc., etc. We have performance and the capacity efficiencies that we just didn't have before. And we have management that actually now works and is achievable without you writing 18 million lines of PowerShell to change a hard disk. Here's the thing you need to think about. Storage Spaces Direct relies on networking. If your network and particularly your RDMA configuration isn't working, Storage Spaces Direct won't work. And we're going to talk about that in a minute. There is no dedupe in Storage Spaces Direct for Server 2016. There is no dedupe. So if you use it, you've got to use NTFS, right? And unfortunately, for all of the benefits, you still have to know what you're doing. Correctly configuring scale-out file server, correctly setting up the volumes, getting all those lovely benefits, does mean actually reading the manuals. There is no magic pill, there is no magic GUI. You do need to know what you're doing. Now, let's get into storage replica. Windows finally gains block level replication. Now, this is quite important. This has nothing to do with scale-out file server or storage spaces direct. This works on any block level solution and supports synchronous and asynchronous. So how many of you are using SANs today? How many of you are paying for expensive SAN replication licenses? Who likes paying for expensive SAN replication licenses? Wow. You happy people over there on the right. So, the beauty of having inbox, of course, is that you can just use it with any block volume you like. It's just inbox. And the nice thing is, underneath the covers, it supports SMB file-based replication. Right? It works on any Windows data volume you like because it operates below the rest of the stack. And it's really, really, really easy to manage because it's just inside the PowerShell. Or you can use Cluster Manager. Now, I really stress it's an important thing. You can light that up on top of your existing infrastructure just by putting Server 2016. And by the way, it does support distributed cluster configuration, so you can do it between Site A and Site B. Fantastic capability. OK, so remember, it's storage replication. So this is not Hyper-V replica. This is not DFSR. This is block-based replication, which means it's going to replicate all of the data from volume A to volume B. Because it is block-based replication, the second volume is going to be offline the entire time that the first volume is active. So it is an active, dark replication solution. There is no file system in the world that can cope with block-level replication happening underneath it without it knowing what's going on. Also, to be very clear, it is a one-to-one replication because it is block-level replication. This is not Hyper-V replica. It isn't ABC. Having said that, though, for people who know I spend a lot of time with the Azure Site Recovery team, it is a very good solution for people who are using ASR. If you want to use Azure Site Recovery and you're doing it on-prem between two of your locations, this is one of the best ways to do replication. OK. Networking. Why do we care about networking fabric? So, most of you will think about this quite commonly. When we talk about fabric, we want to be fast, we care about cost, we care about stability, and we care about complexity. That's what we're talking about when we talk about networking. Now, in Server 2016, a few really big key wins have come through. We can finally reduce the number of physical NICs we have inside of our servers. That's a really good thing. How many people are running around with like servers with like 8, 10, 9 NICs in them with 1 million network cables? Yep. OK. So we can get rid of that problem. We can remove the requirement for dedicated network cards. You know, we don't need to have one for live migration, and one for management, and one for this, and one for the other. And the third thing we really gain is that we gain control of our networking, both our fabric and our software-defined networking layers, via new management interfaces. So let's get into that for a second. Things have got cheaper and easier. Things have got really, really fast in this iteration. However, almost all of you have got to be using RDMA. RDMA means you're probably going to need to buy new networking hardware, and it probably means you're going to buy new switches. And unfortunately, it means you've all got to understand data center bridging, DCB. Fundamental new technologies, and these are not technologies that you can, I should put it, leave with your networking teams. These are technologies as a Windows Server admin you need to embrace. Now, let's briefly talk about NIC speeds. I expect, who's running 100% 1 gig nowadays? Good. Who's running a lot of 10 gig nowadays? Who's moved to 40 gig? No 40 gigs yet, OK. There's a very interesting thing going on in the price point market at the moment, where the 40 gig adapters are, broadly speaking, very close to the 10 gig adapters in terms of price. I would highly recommend, when you look at your next purchasing plans, to put in 40 gig adapters. Because the vector indifference is worth it. What I would also say, though, is, yes, I know 100 gig is coming. Let's just all wait for PCI 4. Without being too geeky, if you put in a 100 gig adapter into a PCIe 3 base server, yes, it runs really well, but you're not getting anything else on the PCI bus. So, not worth doing. Okay, so let's talk about RDMA. Now, fully converged in 2016, thank goodness. A lot of you will probably recognize this diagram because I've spoken about it before in the past. This is what RDMA looked like in 2012 R2. And if you're not familiar with this diagram, the large, ugly red thing with quads in the middle of it is the virtual switch inside of Hyper-V. And do you remember this idea? We all attached virtual NICs and to our VMs, and then what we also did is we had this switch-agnostic team, the virtual teams NIC. And then separate to that, we ran RDMA via the parent OS. In other words, RDMA was run completely independently of the vSwitch. That meant we had to have 2 NICs for RDMA and at least 2 NICs, or 4 NICs, into our vSwitch. So at least 4 or 6 NICs per server. Cumbersome to configure, difficult to live with. In Server 2016, we have this new concept. RDMA is fully supported via the vSwitch. Think about that for a second. We can run high-performance RDMA traffic over the same physical NICs that we're having our VM traffic running over. Now, you'll notice in that diagram, I've now got all 4 of the physical NICs in my server, being able to do workloads for my VMs and drive my parent for RDMA. I've saved time and I've simplified things. And critically, I can now do this model, where I can have just 2 NICs, 2 RDMA NICs, bound to the vSwitch, serving both my VMs and serving my parent. Driven down cost, driven down complexity. And also, we touched on this before, I can also have, therefore, dedicated vNICs into my parent partition for things like management or live migration. So let's just step back and think about that for a second. My investment in hardware is just 2 NICs, but I can expose all of the performance and all the protocols of RDMA and still gain the granular control of individual management NICs, etc., into the parent. Lower cost on hardware, configuration and granular control via software. Now, if you looked at that diagram, you notice this thing I talked about, a switch embedded team, SET. SET is not load balance failover. It is not 2012 R2 teaming. SET directly connects your physical NICs into your virtual switch. The vSwitch talks to them directly. There is no configuration you have to do on your physical switches. Nothing at all, right? It is the only way you can do RDMA into your hypervisor, if you do SET. I'll take questions at the end if that's okay. If you want to deploy the network controller, you must use SET. And for your own reference, inside 2016, there are effectively 2 networking stacks. There's the 2012 R2 networking stack, and then there's the new switch embedded team networking stack in 2016. Now, here's an interesting thing. If you look at any Microsoft documentation, they're going to recommend that you use SET on your storage servers. In other words, where you do RDMA is via this vSwitch. But that means that you've got to install Hyper-V. So if you're using disaggregated and you're using storage, you've still got to put Hyper-V in there. Now, there is absolutely no technical reason to do it. It's just the way they built the application. If you don't have to do it that way, but it's the way they're recommending it. And we can talk about that more later if you want to. OK. Yes, we are going to overrun, but there's nothing I can do about that. So, RDMA considerations. For those who aren't familiar, there are 2 main standards in the RDMA world. One is RoCE, and one is iWarp. The 2 main vendors are Chelsio and Mellanox. There are rows between which one is better and which one is faster. We use both, and both work very, very, very well. There are pros and cons to both. Almost all of your hardware vendors will be probably shifting Mellanox adapters as their preferred option. So, data center bridging. This is the caveat. RDMA requires data center bridging. For those of you who aren't familiar with it, data center bridging is a configuration protocol you have to set up on your switch. This means that for RDMA to work, you have to get your networking team to make switch changes. You then not only have to get your network team to make switch changes, you have to correctly configure your network cards. Now, that only applies if you're using iWarp, if you're using RoCE. For iWarp-based RDMA, though, you don't need to do any DCB. So it's much, much, much simpler to set up. However, if you are going to do hyperconverged, Even if you're using iWarp-based RDMA, you must use data center bridging, because data center bridging is the only way of doing hardware quality of service on RDMA in Server 2016. So, here's the important takeaway. Anybody who tells you you don't need to do DCB with iWarp is lying, because it isn't true. If you need to do hardware quads, which you will, you're going to need to do it. Now, why is this DCB thing so important? RDMA, as you know, occurs on the physical NIC. It occurs outside the Windows stack. Now, if it occurs outside the Windows stack, the software component can't control it. And if RDMA is left unchecked, it will consume the entire network performance of your NIC. But think about that for a second. This NIC is now being shared between your vSwitch and your VMs. So if you don't set quality of service on your RDMA NIC, your VMs suddenly don't get any performance. I have seen people do testing where they've gone, wow, my RDMA storage network runs 200,000 IOPS a microsecond, but their VMs can't even ping. RDMA ate up their network. Okay. Now, one more thing I'm going to touch very quickly on before we move forward. You have to turn on quality of service with Storage Spaces Direct. Now, if you do not turn on quality of service, you're going to have a situation where your storage system could potentially become completely saturated by VM workloads coming in. There is a caveat to this, though. When you turn on storage quals, you're going to take a 10 or 15% hit in overall storage performance, because the quality of service has to sit in the data path and analyze what's going on. However, I'll still take the 10 or 15% performance hit over having my storage system grind to a complete halt because there was no quality of service in them. And I'm going to talk about quality of service later in the week. Now, I'm going to talk very briefly about network considerations. So, we've spoken a lot about Storage Spaces Direct. We've spoken a lot about RDMA. We've spoken about vSwitch. Here's the downside. You've probably got to go and buy new hardware. You probably haven't got DCB support on your switches today, but please don't go and buy wholesale network upgrades. Here's what most people do. Go and buy dedicated storage switches, right? Just go and buy the switches for your Storage Spaces Direct configuration, your hyperconverged configuration, right? Do a small-scale storage switch and don't have a row with your networking teams over wholesale network upgrades. Much, much, much better approach. Now, guys, I'm going to run over by about 10 minutes because if that's okay. So hopefully they'll be okay with it. So let's now talk about the networking very quickly. There are three topologies you can see here. The topology you should be using is the one in the middle. Linked switches, highly available configuration. Remember, your entire system now is using network as its way of keeping data consistent. If you don't use a highly available switching fabric, you're going to have data corruption if a switch goes offline. I cannot stress this enough. Option 1 is not viable, and option 3, no modern switch vendors do. Cannot stress how important high available switching is. Right, we're going to Hyper-V, and I will try and get through this as quickly as possible. As you know, the job of Hyper-V is to virtualize everything, be really, really, really fast, and get right out the way, right? Because here's the funny thing about hypervisors. Actually, I don't want to care what the hypervisor's doing, I just want the thing to work. And what I also wanted to do is make it easy for things like storage replica, DR, etc. Now, there's a bunch of changes actually in Server 2016, which are kind of useful to talk about. The first thing is that guess what? We can finally do 2012 R2 2016 in-place upgrades and migrations of cluster. Good? Right, hooray. Good. It's a fantastic new capability because it means you can do mixed mode clusters. Other key things to note. Clustering now uses certificates underneath the covers for auth. Right? Fundamental change, much more stable. Now, other key things to note which are really important is there is also the concept of an Active Directory-less cluster. I'm going to be really, really, really honest. Who here is an SQL admin and likes SQL? Good. You'll love AD-less clusters. Right. So the SQL gentleman down here will love it. The rest of you don't care. Absolutely pointless for Storage Spaces Direct because SMB can't use where it relies on Kerberos, so it doesn't work, basically. There we are. I've covered the AD-less cluster scenario. Right. Now, Many of you will be familiar with Generation 2 VMs. Now is the time to really start using them if you're not already. Shielded VM, which you saw in the keynote today, relies on it. And critically, for those of you using remote desktop services, they now work properly with shielded VM. Sorry, not with shielded VM, so sorry. With Generation 2 VMs, right? Including virtual GPU. So, for all of you who are using those services, now is the time for Gen 2 VMs. I'll skip over that. No, there's one thing I'm going to cover in here. Note, RDMA is now supported into VMs. And by the way, there's another demo you're going to see later on in the week. RDMA is also now possible into Windows 10 Client. So for those of you who are doing very high performance client or VM activities, you now have RDMA support. So for certain use cases, it's really, really important. Something else I'm going to bring out on this slide. SRIOV works via switch embedded teaming. No longer do you have to do a one-to-one mapping between physical NIC and a VM that wants to use SRIOV. So you can get all the performance, all the low latency of SRIOV without dedicating a physical NIC to it. Very, very, very helpful capability, especially for service providers. Forgive me, I'm going to have to skip it because we don't have time. I'm so sorry. So let's jump to shielded VM. Who saw the keynote? Who saw Dean's demo? Good. This is my favorite feature in Server 2016, believe it or not. So, fundamentally changes the way we think about security. For the first time ever as a service provider, I can say to my tenant, I cannot look at your data. I cannot fiddle with your VM. I cannot steal your stuff. Fixes that problem. For the first time ever, your application admins don't have to trust your Fabric admins. But of course, we all work in organizations where everyone gets on, don't we? Yes, thought we did. Now, as you saw in Dean's lovely demo this morning, they showed you being able to modify and hack an AD Hive. Here's the really important things about shielded VM. It allows you to do protected encrypted VMs that can not be modified from the Hyper-V level. You can't look at the console, you can't steal the VHDX, you can't look at it, you can't change the configuration. You can turn it off and on, and you can back it up, but that's all you can do. There are configurations though. First things first. Shielded VM relies on something called the Host Guardian service, which again we've spoken about during this week. That service can't run on Nano, but must run on hardware. So you can't use Nano for it. Other things to consider, if you really want to get the most out of it, you need TPM2 chips in your servers. TPM2 is the thing that all your laptops have in them. TPM is what all your laptops have in it to make secure boot work. Servers now have them, which means you need to go and buy new servers. There is an AD-based alternative option. However, there is one other gotcha that I should highlight to you. There is no encryption between shielded VMs when they talk to each other. So, if you've got two shielded VMs and their applications have a little chat, the only protection you've got is the application level encryption. Think about that for a second. There is no inherent fabric level encryption for networking between shielded VMs. Very, very, very important little gotcha. And by the way, if you will attend Dean's session tomorrow, please yell at him about it, because I have for the last 2 years. Now, software-defined networking. I'm going to do this as quickly as possible. For those who aren't familiar with software-defined networking, it is Microsoft's network isolation technology that allows customer A and customer B to not see each other. In other words, it stops soft drink vendor 1 seeing soft drink vendor 2, even if they are using overlapping subnets. Critical change in Server 2016. Microsoft has now standardized on the industry standard VXLAN, not MVGRE. So all of your services based on VXLAN will now work. Now, this pretty diagram covers it quite well, but what it really shows is that blue network and blue computer can only see each other, and red network and red computer can only see each other, but they're all running on the same physical fabric. As a service provider, this is how I make my money. Now, the network controller is what I really want to talk about. Who's deployed software-defined networking in earlier versions? No one? We have one, thank you. Okay. Now, for people who have done this, you basically had to use VMN. It was almost impossible to do without VMN. However, finally, Microsoft has put a management solution for software-defined networking in box. No requirement for VMN, and a true distributed scale-out software-defined networking solution. So let's talk about this. Here's the good points. No VMN, and software-defined networking now has true scalability. It's built on muxes, it has true scale-out capability. Here's the bad news. It does not support DHCP. You've got to use IP pools just like you do in Azure, which means you can't use things like Windows deployment services. It does not support multi-site. So you cannot use the network controllers to control multiple sites and correctly have the incoming virtual networks route the traffic. Remember I said route, not route, even though I'm British, to the correct site. And also, and this is the last thing, which is very interesting if you're a system admin like me and not a networking guy, you have to understand BGP on your physical networking devices, otherwise it doesn't work. Now, the network controller topology is quite interesting. You have two VMs running the network controller role, which then inject themselves into the vSwitch on your Hyper-V engines. Then you have VMs running the border gateway and the software load balancer. Then the network controller manages all of those. In other words, this is a VM running the network controller role, which is a scale-out role, driving VMs providing new edge gateway services and software load balancing, directly integrated with Hyper-V at the bottom. Very, very, very good topology. Now, let's talk about virtual networking services. These have been around for a while inside the Windows Server. The first one is the Edge Gateway, as it's now called. This is the thing that lets customers connect their incoming VPNs and their incoming routing connections into a software-defined network. It used to be an active-passive clustering configuration. This now has true scale-out, so that I can just spin up more and more instances of the gateway, and then the incoming connections will be automatically load balanced between it, using the software load balancer. Again, I won't labor on this because I'm very aware we are short of time. The software load balancer introduced in Server 2016 is a true scale-out MUX. This is not network load balancing, NLB, which was inside of Server previously. This is a true, grown-up, scalable software load balancer. Let's think about that for a second. In box, we now have a true load balancer that can distribute load across multiple IP, and it is multi-tenant aware in box. Now, I won't talk about firewalls, it's boring. So, we almost get to the end. What I have spoken about today, therefore, is the following. We're starting off with hardware. And what we're then talking about core fabric, storage and compute, protection, isolation, and control, and the services layer. What does that really look like? So, we spoke about at the beginning of the session, we talked about these two UI servers with two RDMA NICs. On top of that, we're building Windows Server 2016 Nano, switch embedded teams with a Windows cluster. In other words, that core fabric. On top of that, we are then building Storage Spaces Direct and Hyper-V. They're now running on the same box, inside the same cluster. On top of that, we are doing shielded VM to give us that protection, that isolation. We are using the network controller to give us tenant isolation and virtualized network services. And then at the top layer, we have lovely things like software-defined networking and remote desktop services. And by the way, I would highly recommend attending some of the later sessions about remote desktop during the week. Now, let's sum up very, very, very quickly. Windows Server 2016 has redefined the software-defined data center. It's driven a number of benefits that, again, have driven down cost and deliver us a huge number of genuinely helpful new services. But the learning curve is steep. And I have to labor this point. Fortunately, the documentation is actually quite good now. But you cannot apply your 2012 R2 knowledge and evolve. You must learn and invest in that learning. And if you do, you will have a brilliant experience with Server 2016. You really, really, really will. Now, very briefly, other sessions I would highly recommend you attend. I would highly recommend attending Klaus and Ned's session on Storage Spaces Direct. Dean's session on shielded VM is a must attend. Right? Also, if you are interested, I am doing some sessions on storage and on Nano. helping in those sessions, which you can see in red. And also, if you are Lenovo customers, I'm actually doing a couple of Lenovo sessions later in the week, so I'd highly recommend you joining those as well. The last thing I must highlight is at the bottom, you'll see the sessions on networking, which are being done by Don and Greg. If you want to understand more about the networking I discussed today, please attend those sessions. And very lastly, if I haven't bored you all enough this afternoon, and you want more of my abuse, you'll find me in the Microsoft Expo booths or near the Lenovo stand. And with that, I'm going to say thank you very much indeed.